Hello everyone, this is Dennis, and you're on the Den Electro channel. I'm sure many of you, like me, have a stash of these cell phone chargers. They typically range in power from 2 to 10 watts. Theoretically, they could be used for something, but the problem is that they produce very little voltage, only 5 volts. They can, of course, be converted to a different voltage, but not everyone knows how to do it. So to keep our chargers from sitting idle, clever Chinese people have come up with an unusual device. Meet the voltage boosting adapter cable. One end of the cable has a standard USB port, and the other has a male connector. With this cable, you can turn 5 volts into 9 volts. Now you can power modems, radios, TV boxes, old consoles, or even turn on LED strips. For the latter, there are models available that boost voltage not only to 9 volts but also to 12 volts. You could also try something more exotic. For example, powering a 12-volt fan from a power bank. Of course, you can also connect a router or modem if the power goes out at home. Of course, many have already guessed that the cable doesn't perform any miracles. It can't increase voltage. A step-up converter does that for it. It's located here. The manufacturer promises that it can output 9 volts and 700 milliamps. We'll find out now whether this is true or not. To test this wire for maximum power, I put together a small circuit. I'll apply voltage from this device and monitor the current drawn at the input. This tester will display the output voltage. And this current is the current drawn by the load. I'll load the converter with an electronic load. It's off camera. I apply 5 volts to the input, and the output immediately shows 9 volts, so I begin increasing the load. As you can see, with the stated maximum current of 700 milliamps, the voltage has dropped to 8.86 volts. At this point, the input current is approximately 1.6 amps. This means the power consumption is almost 8 watts. And if we also multiply the output voltage and current, we get 6.2 watts. Well, if we then divide the output power by the input power and multiply by 100, we get the converter efficiency. It comes out to 77%. Not a bad result, but we'd certainly like it to be higher. If we increase the load further, the voltage drops even more. At 1 amp, the voltage is just over 8 volts. Now I'll try lowering the input voltage and see if the converter can work. I'll set the load current to the same, 700 milliamps. I start lowering the input voltage. 4.9, 4.8, 4.7. Everything's going well. Up to 4.2, the output voltage remained the same, but after that, it started to drop. So it turns out that the supply voltage can be lowered to 4.2 volts. And the converter will work just as well, outputting 700 milliamps. Now I'll reduce the load. The current will be 400 milliamps, and the voltage will recover slightly. I lower the voltage further. Now the voltage can be lowered even further. 3.9, 3.8, 3.7, 3.6, and the output remains at 9 volts. With this load, At 3.6 volts, it consumes 1.4 amps. As you can see, the converter is so powerful that it can operate not only from cell phone chargers but also from lithium-ion batteries, which have an operating voltage of 3.7 volts. When I increased the output voltage to 3.2 volts, the voltage started to fluctuate. It started jumping up and down. Apparently, the converter was trying to reset itself. When I reduced the load, the voltage recovered. Then I reduced the load slightly, to 200 milliamps. I'll try reducing the voltage again. I was able to reduce it to 2.7 volts, and the voltage dropped slightly there. If the load is reduced, and the current consumption is reduced to a very small value, around 100 milliamps, the voltage is restored. Now the voltage can be lowered further. It can be lowered to around 2.2 volts. Then the converter simply shuts off. Although it still produces voltage, it's essentially the supply voltage. The converter doesn't increase the voltage. But if the load is removed, the voltage is restored again. Well, now it's time to see what's inside. To do this, you can separate the halves of the connector housing with a thin knife. Inside is this small circuit board. This is a 2-amp 40-volt Schottky diode. This is a choke, slightly broken. On the sides are ceramic capacitors. Below are resistors. And in the middle is the heart of the converter, a 6-pin AL101 microcircuit. This is, of course, its code name, but in reality, it's called SD6271. It operates at 1 MHz and can deliver up to 2 amperes of current. For such a tiny thing, the power is quite respectable. It's recommended to supply 2.6 to 5.5 volts to the input. During my experiments, I applied 6 volts and everything worked just fine. Fortunately, they didn't skimp on the cable. It's about 1 meter long. Many cell phone chargers have cables that are half as long. The connector size is standard, 5.5 by 2.1 millimeter. The pinout is the most common, plus on minus. If you need to swap the positive and negative leads, you can simply resolder the wires on the board. If you need this wire, you can purchase it by following the link in the description. AliExpress sells 5, 9, and 12-volt versions. The 12-volt converter also outputs 700 milliamps, but I think the 5-volt wire only outputs the current for your charger. Most likely there's no converter there, and it's essentially just an adapter. That's all for today. Like and comment if you enjoyed the video. Subscribe to my channel if you haven't already, and bye everyone.